Alright, welcome back everybody. In this video we're going to look at examples 1 to 3 from the lengths of curves lesson. Hopefully you've read through in the complete notes, you've read through the derivations of all the formulas for finding lengths of curves. After you've done that, it's a reasonably simple process. We want to make sure that we're looking at a smooth curve with no exceptions to that whole smoothness concept, otherwise we'll have to deal with those. But outside of that, it's a very simple matter. We need to find dy dx for the given function. And so in this case, dy dx is equal to 2x. And then our arc length formula is going to be square root of 1 plus dy dx quantity squared. And we're going to integrate from one end of the curve to the other. So from 1 to 5. And so my arc length here is going to be the integral of the square root of 1 plus, and you can expand that out if you want to, or you can leave it as the quantity 2x quantity squared, whatever you're most comfortable with. I tend to expand it out usually when I'm typing it in so that I'm not adding all kinds of parentheses into my integral. And we find that the length of this curve is 24.395. Easy enough. Alright. Now in example 2 we have a curve where we have x as a function of y, and we have y coordinates for the endpoints here. So in this case, instead of using the square root of 1 plus dy dx squared as our integrand, we're going to write our integrand in terms of y, and it's going to be square root of 1 plus dx dy quantity squared with respect to y. So here we find dx dy, and dx dy is going to be 2e to the 2y. And then we'll set up our integral to find the length of the curve. We're going to integrate from one end of the curve to the other in terms of y. Square root of 1 plus dx dy quantity squared with respect to y. And now again, it's a matter of punching things up on our calculator. We'll take the integral of the square root of 1 plus 4 e to the 4y, so that's what I get when I square that. And again, as usual, my calculator is going to be using x instead of y when I type in my integrals. Make sure I typed all that in correctly. Okay, close the square root. Should be good to go. And we get that the length of this curve is 78.777. Okay, one more example in this video. Let's look at example 3. There's some narrative here as far as times when we'll have difficulties with curves, specifically when curves have vertical tangents or when curves have corners or cusps. And so we're going to look at those. In example 3 here we have a curve that if we actually looked at the graph of this curve, we'd see that there's a vertical tangent that exists at x equals 0 because the derivative is undefined there. And that can pose a problem for us when we're trying to find the length of the curve because of what's going on in our integrand. So what I would do for this one, whenever we have a vertical tangent, usually the best scenario for us is just go ahead and solve this equation for the other variable. We get x equals y to the third, and then handle finding the arc length in terms of y instead of in terms of x. So I find dx dy is 3y squared, and so my arc length formula is going to be the integral, and now since my integrand is in terms of y, I want my limits of integration to be the y coordinates of the endpoints instead of the x coordinates. So I'm going to use -2 and 2 as my limits of integration here. And then it's calculating time. go ahead and set up our integral. The square root of 1 plus 9 y to the fourth from negative 2 to 2. Uh-oh, I think I forgot a parenthesis. Yep, I sure did. Let's insert a right parenthesis there, and now everything should work fine. And we've got our arc length of 17.261. Now, what would have happened if I had tried to find this arc length with the vertical tangent? Sometimes our calculators can overcome that, and sometimes they can't. So let's take a look at what would have happened if I tried to do it that way. dy dx is equal to 1/3 x to the negative 2/3. And so if I tried to find my arc length that way, it would have been the integral of the square root of 1 plus quantity 1/3 x raised to the negative 2/3. There's the exponent, close the quantity, and then we need to square that quantity, and then close the radical. And let's see how my calculator handles this. Like I said, in my experience, sometimes my calculators have been able to overcome this situation, sometimes not. In this case, we're getting a domain error, which is my calculator telling me, hey, this derivative is undefined somewhere in the interval where we're trying to find the integral, and so it's causing me problems. All right, so that's one way to deal with it when we have a vertical tangent. All right, that's the end of this video, and we'll come back next time to look at a few more examples of finding arc length in the next video. All right, have a great rest of your day. See you guys next time.